Hi guys, I'm Alexander, and today we're going to go into our third part of our 3-part series video of this inverter, 12 volt BESTEK 1200 watt inverter. Or what is our review without some trial error. In this video, there's trials, and there's error, and there's love, and there's love loss. But it's still my BESTEK inverter. I know I didn't sponsored by endorsed by BESTEK in any way, shape, or form. Anything I say in this video is my opinions and my opinions only. In this video, you will see it. Stick around for the end of the video, and I will show you my ups and my downs on this inverter. Still love it though. The quality and the engineer that go inside of this obviously superior. Than the low cost inverter out there. This one is more expensive. Overall, I like what I see. So here's my setup. If you notice, I'm using the same cable that they sent with the inverter. Positive, negative. Positive, negative. So from here, all it requires you to do to get this inverter going is to push this little power knob. It will illuminate with a green light, indicate that inverter is on. Also, the screen would light up. So I go ahead, push the little button, there you go, indicate inverter is on, and it would cycle itself and read the display. So as you see on my display, I have 13.0 worth of battery power, output power 110 AC, and I have no watt coming in. So this is a test where we test our lower load to see how far this inverter will trip out. First up is an household iron. This iron is 1000 watts, and it is first up to see the performance of this inverter. What I'll do, I turn the iron off, and this is the plug. I'm going to plug directly in the inverter. Now, as soon as I start to increase the volume on the iron, this red light will indicate that the iron is on. So there you go. I don't know if you can hear it, but the fan have chipped in and my battery volt have dipped. If this dip behind that 10 volt, the inverter will trip out. Not because of my limitation on the inverter, but it's a limitation on the battery. This inverter, anything below 10, it will trip out. No, the iron has gone out, not because the inverter doesn't have the power, but because the iron has turned down low and low setting. So let's go a little bit higher. Once the iron is hot enough, it will chip out just like that. See, as you notice on the wattage, I am only pulling 700 watts, and I said this is a 1000 watt iron because the iron doesn't need all of that 1000 watt to run it. Let's turn it up a little bit more. So I put the iron on the highest. It's still drawing 753 watts. Let's see which would go out first, if the iron will get hot before the voltage dip behind 10 volt. Still putting 700 watts. And the fan has kicked in. As I said, I don't know if you can hear it. So the iron is hot enough, so it chipped out, and so I'm satisfied. This is also a 1000-watt hot plate. Guess all of my products are bought from the same company. Just noticing that. But anyway, this is also a hot plate, something that you hot food on, and this is drawing 1000 watts. I'm going to plug this in also. So the hot plate is plugged in here, and hot plate is over here, and I am going to go low. So it's on low, and it's drawing 800 watts. I suspect if I go medium, the hot plate draw more to get it warmed up than the high end. So I suspect if I go a little bit higher, the battery would suck all the way down. So let's do that. So that's medium, and it still remain at 10.2. What if I go high, if it will chipped out? Let's try that. Okay, so that's all the way up. And then hold the joint 760 watts. We just give it a minute to set the hot plate to the hot enough, so it will chip out just like the iron. But while I'm here waiting for that to be hot enough, there's a few little thing, lights are indicating at the top of this digital meter, and while they're not going to be on at this moment, I'm going to just explain to you. Here at the top it's OV, and this means over voltage protection. So if this light comes down, that means something wrong. Here it's under voltage protection. Next one is OL, and it's overload. The next one is SC, and it's short circuit current. Next one is OT, over temperature. Oh, that's really hot. Start the back off of the watt that it doesn't need. So overall, I guess it can power up on hot plates. So I'm going to go to something bigger. My next stop is this electric kettle water heater. Now this is pulling 1500 watts. I will turn it over in a moment so you can see that. There we go. Let's focus. There we go. On the bottom. Right there, 1500 watts. This is a mischief. Wonder if it can do 1500 watts. Alright, a moment of truth. There's a little less sun outside, so can't have my battery going down. They're just only going up at 12.7 volts, no problem. The kettle is full of water and it's ready to go. What do you think, guys? Would it run it? This button. Once I push this button, it's going to be indicate red. That means it's on. Wow, as you can see, it dropped right down to 9.7 volts. I don't think it's going to manage. There you go. And so the battery dipped too far it cannot manage. And I will make the battery charge up some more, and as you can see, the inverter turned off to protect itself from under voltage. Haha. So I'll let those batteries charge up a little bit more and continue with this test. So I must say before this kettle chip out this inverter again, it has nothing to do with the 1700 watt I can pull from this, but you have to have a strong battery. My batteries are not that strong, so each time the load goes over 1000 watts it starts to dip, and the inverter might soon go because it's just below 10, and the kettle is putting 1001 watts. So I must conclude that this inverter can in fact run that kettle, but my batteries are not that strong. I will check some other stuff, because inside when we pull this we see 3 different leg of current. We're going to check the difference between ground and one leg. Other cheap inverter does not have this function, so if this one have that function, that means it's reasonable good. So to remove the child protection, to push anything in this, unless a child figure that out, you need to push one of the probe right here at the top, and once the top one open, this one is also open. So line 1 to ground, as you see on the meter over there, it's reading 58 volts. Okay, line 1 to line 2, I don't know if it's a limitation of my meter over there, need battery or what, but I'm only getting 97 volts. So that cannot be right anyway, but let's check line 2 to ground. I'm going to take my probe like this little hole right here, and I still getting 62. 58 and 62 would give you 120 volts. So line 1 give me 58 and line 2 give me 62. So this is outperforming any other cheap inverter. Any other cheap inverter doesn't have support line giving you support, giving you half of the current stable. So that is remarkable and more outstanding. And so guys, I concurred, it's a limitation of my battery, cannot run that hot water heater, but the inverter can definitely manage that 1500 watt over there. So I'm the type of person that have that determined and motivation. I have tried this kettle to work on my little inverter for the last couple of hours, and because my battery is not that strong. But in my previous 200 video, I get a comment that this inverter cannot pass 800 watts, and to prove that, I go to the extra length to do that. So now I have put a bunch of things on this inverter. You can see 2 plugs is there, so I plug in a bunch of stuff, including the kettle, which is 1500 watts. My intention to show you that this inverter can pass 600 watts. And with a push of the switch on the kettle, the inverter will peak up 600 watt or more. You see that? Inverter is at 746 watts. So it's safe to say that this inverter can pull up to roughly 800 watt, I should think, because it's handling 700 watt comfortable. And so it's what I start to say. I have a little disclaimer. I have praised this inverter so much that I thought I'd buy a bigger one, but it have a little fault. At 400 watts, fan on the inverter will not shift in until this inverter is at 400 watts or higher. Less than 400 watts, the fan will not shift in, and so that after 45 minutes running that inverter under 400 watts, inverter will go into overheat mode and then shut down. And I'm a little bit disappointed about that. Because what if I'm not putting 400 watts at any time in the day? I'm left with a shutdown inverter for the whole day. If I'm not home and I intend to use this as a backup, for any a reason at all, and I have some things on it, which doesn't require to go over 400 watts, after 45 minutes, the inverter will go into overheat mode and shut off. So that is my little disclaimer, even though I think it's still a great inverter.